today I will discuss about my research, AR BIM validation, the perspective of novel applications in site management. And let me introduce myself briefly. My name is Yiran, Jing, and I graduated from the Bartlett School at UCL with the digital innovation of building and site management. And now I work in Shanghai for 1 year at the Tongji Architecture Design. Let's start with my research. Very thanks for able help me quite a lot. The structure is I separate in 5 main parts: the background, the hypothesis, and methodology. The third one is a experimental design. The fourth is a experiment result, and then we got a result analyze. Let's move on the first part, the background. To be honestly, on the construction site, there are several problems we faced. The first one is as quite a large, dynamic, and complex sector in the construction sites. They have the multiple things we need to consider as a manager. Then the second one is that the workers' lack of the knowledge of design. The construction workers, it's very hard to read, understand about the 2D drawings in the 2D traditional function. So let's we think about, can we have an alternative way to instead of it? And the third one is the measurements in details and the work information are less accuracy and traditional functions. On construction sites, we always measurement use the distance measurement, but it's just basic on different points. So can we just think we do the AR imagine just based on the one point, and we can got all the measurement from the different part. It will be very accuracy, right? And the final one is that high expense in change, conflict, and potential law issues. If we see the round and the construction site, we need to do quite a lot change from the 2D drawings with the designer, blah, blah, blah. But if we use just the AR, can we just change directly and upload it on the federate model, and all the people in this project can know that changes? So we do the hypothesis and methodology for our research. For the hypothesis, we just assume that AR applications can check design validation more accurately and efficiently than the 3D BIM. We got a hypothesis. We use the main methodology for control group experiment to test. So in this experiment, there are 2 groups. We set control groups and experiment groups. And we setting with control variables and 1 independent variable used to test these hypotheses. We control the section with the participants' gender, age range, and healthy conditions. Plus, the normal information will affect our results. We just set the same educational background, same work experience, same studied major, and AR using experience for our 6 participants. Then we control the independent variable session is about 3D models. That is the 3D modeling plus the 2D drawings. Then we set for AR mobile image. So in the limit time, which group can find more difference between the virtual objects and the physical objects is what we want the results. And we invite 6 people to participate in this experiment to achieve the purpose of this research. We need to prove the data as much as they can. And because just like 6 participants, but we want to get more data, we use the Latin square function to do that. So we just set the control group and experiment group separate for 3 and 3. We have 2 arrangements. Arrangement 1 is with the control group, and group 2 is for experiment group. Then in the arrangement 2, we just inverse them to get the results. So let's move on part for experiment design. I just separate into 4 main parts: the experiment preparation, the pre-experiment questionnaire, the research experiment, and the post-experiment questionnaire. For the experimental design, we do the preparation for the accuracy in millimeters model. So we use a laser scanner to survey the control measurements, and we generate a point cloud and then clean up. We set up the Autodesk Revit and import the point clouds. Then we model in 3D geometry and add chosen detail. Then we got accuracy check and this dissemination method. And very thankful for the civil engineering department and got this model. The purpose we got a model is scanning the accuracy of model and create a point cloud database. And we achieved the model level for level 4. It's about the level of detail for 400. So it's very clear to get the detail in the modeling. And we just use the hologram transfer to the AR model building and comparing with the reality. We got the model in LD400. Then we just use this model to get 3 different plans. The first one is the original model, and then we, based on the original model, change a little bit to the AR BIM, that we can get a different plan to compare with the 3D BIM, also the different plan. But we base the different plan to compare how fast the participants can find the difference with the original models. And before the experiment, we got a pre-experiment questionnaire to control our variable sessions. It's based on the question for 10. It's about the gender, age range, work experience in the construction industry, the level of education, the major, and how you use the AR, how interested in AR, and do you play the video games? Because some video games is based on the AR technology. And do you use 3D modeling before? Do you have ISAT? And how much is that? Because it will affect that you do the experiment without. Then we start with the research experiment. As you see, there have like 4 different image. The first 2 is about 3D image, and participant will use the 3D models and the 2D drawings to and the place to find the difference. And then as you see that there are 2 images for AR beam image. That means we just set the base point and we use the 1:1 scales to show our design, and you can compare the design with the reality. What the difference? And after our design, we set the post-experiment design questionnaire. It's about 7 that how do you feel is using the AR mobile, and how do you feel use AR HoloLens, and what do you think 3D beam or AR beam can be improved, and do you want to recommend to others about this one, and how do you think the 3 method can be improved, and any difficulties by AR during the experiment. Because we do the experiment, we just use the 3D beam and AR mobile. But after experiment, we also have a little bit try about AR HoloLens. Because some technical problems we not use during the experiment, but other participants try to use the AR HoloLens for fun. So that's the reason we do the questionnaire. And after experiment, we analyze the database from the qualitative surveying and quantitative surveying. We can find during the whole experiment, the participants use 3D beam. The average time is about 9 minutes. But for the AR beam, it's just like 3 minutes for each one. So the AR is faster than the traditional function way to do the research. And we use all the experiment data. We compare the 2 findings. It's about the accuracy rate and the shooting rate. The accuracy rate is that the participant right findings divided by the design all difference. And we can see the diagram that shows the AR mobile is 100% accuracy rate. But for the 3D beam, they're approximately about 70%. That means if we use the AR mobile, we can just directly to see all the difference, and 100% wrong, we can show very clear and directly. For the shooting rate, it's about the participants' right findings divided by participants' all findings. We compare these 2, we can find the AR have a 60% shooting rate, but for the 3D it's have like 70% shooting rate. For the participants' feedback, we can easily find that 4 people give mark 4 to the experience. And comfortable level and utilities also seems good for the AR experience. To analyze the result that we got from the experiment, we can find there are 3 base points why the hypothesis is not as expectation as we thought before. The first one is the experiment uncertainty. As we can easily to find that when we just use AR mobile, the performance of image are easily floating up and down with following the AR beam when the participants doing the experiment. By analyzing of the experiment process, if the participants want to reduce the uncertainties, they needed to observe the level of objects as same as real places. Moreover, another challenge is the difficulty of the visualizing digital information due to the sun's light. If we doing the experiment in a different period of day, the sunlight will be changed and it will affect the results we observed. The second part is the AR beam imperfections. As we thought, AR mobile needs a high-level headset to the machine. If we want to solve this problem, we need to a extremely high-end headset for a better choice, such as the HoloLens or high-end cell phone. To the final one is for the small sample size. The results of this experiment have limited statistic power to support the hypothesis. Because the sample size is very small, only 6 participants did this experiment. Smaller sample size have lots of bad impacts on the experiment results and checking if the hypothesis is right. For the further research, we hope that the combination of AR with 3D BIM will be based on a large number of participants, at least 100 participants, that can make experiment results more reliable and attractive. Moreover, adding another experiment group such as high-end headset like HoloLens or Magic Leap is also necessary for the application of AR BIM, which can be more easily to demonstrate a relationship between the 3D BIM and AR BIM. Although AR high-end devices are smart and there are lots of literature supporting the AR technologies used in the industry or construction process in recent several years, AR still needed to be more developed and the user experience design should be improved, which is also one of the main concerns raised from our participant feedback. Many thanks to all the listeners. If you have any question, you can email me directly. Thank you.